Okay, before starting this chapter, let me ask you one question. Okay, like among these three, which one is number one? The first one, second one, or third one? It's kind of stupid question or some dumb question, right? But what would be your answer for that question? Maybe all of them, right? Or maybe the specific ones you like? Or no answers for that, right? So look at here. The real meaning of number one. Can you explain that? Then according to that, you can choose the answer for that question. Right? What is the meaning of number one anyway? Right? It's just kind of some abstract concept. Okay? And we cannot see it, right? So these are actually like yes and no. Like none of them is that number one, right? These are just the notation or symbol of that abstract concept. So the answer is yeah, maybe all of them or none of them, or maybe just specific ones. In different culture, they use different notation for number one. Like in China, they use like number one, number two, number three, like that, right? Doing that. So these are just symbol to denote that abstract concept. So the question is, then what is that abstract concept for number one, number two, number three, like that? So in historically, humans use those abstract concepts as kind of God-given, right? It's too natural. Number one, yeah, it's number one. I have one apple, you have two apples. No brainer, right? It's naturally we understand it and we use them. But if you're really digging into the real concept of these numbers, it's really difficult question. And even more important question is, yeah, why 1 plus 1 equals 2? Why can that be something else? And I believe I already gave some other way to look at the meaning of plus, right? So 1 plus 1 could be any number. We can make it. So everything depends on how we define it, how we consider that. So in 20th century, the mathematicians look at the concept of these numbers in different way. So we treat that as not God-given ones, but like something we can actually define it and we can make it for our own use. And the notation could be anything. So we are going to still use that traditional number symbols, right? But let's just try to understand and define the meaning of it. Okay, so from this chapter, next several chapters are really dealing with the modern way of defining numbers. Okay, so you ready? And try to open your mind. Okay, and just cut down all the knowledge you already have, like about numbers and anything, just to be free. Okay? And modern math is based on set theory. So set theory is kind of basic tools for anything you want to do in math. Okay, so same thing happens in number system. When you construct our number system, first in this case for natural numbers, we need to know how to handle the sets, right? Set operations, everything. So I'm going to assume you know about that. Now, using those ones, let's just define our numbers, especially in this chapter, the natural numbers, 1, 2, 3, 4, 5. But to defining it, we need to start from 0. And we already covered that one, right? In Europe, when they still says the natural number includes 0. In the United States, we said that one is a whole number, right? 0, 1, 2, 3 is a whole number. Okay, but that's something else. But anyway, so let's just say this notation for the empty set in the set theory, which means it does not have any element in it. So empty set has a different notation. Sometimes we can just use this open and close braces. without putting anything in between them. So we are going to use either way, right? So we just match the number of 0 or number for any natural number is this number of elements in a certain set. And we just build those sets, the sequence of sets, and assigning to each natural number. Okay, so temporarily you might think like number 1, 2, 3 is just the name of certain set. Okay? There is something in there. Okay? So like a set A equals A, B, C, we are so familiar with doing this way, right? So like that, we just give a name for very specific sets. And those names are our numbers. Okay, so let's look at here. 0 is assigned to the empty set. Okay, no element, so I think it's reasonable. 1 means it has one element in there, and that element is nothing else but the previous number. Okay. So right now, we are going to use kind of interchange the word like number and sets because it's the same thing, right? The number 2 is a set, right? So we're going to say number 2 or we are going to say set 2. Okay. So number 1 is a set containing number 0 as its element. Okay. Then how can you make it? This is really important kind of procedures or method to construct that new set. It's actually using the previous set or number, which is a set, and take the union of a set which has the previous set as an element on it. Okay, it's very very important concept here. So let me rewrite this one again. That can be written by empty set union a set of something, right? So when you take the union of these two sets, it's going to be another set, but the first one is empty set, which means we're not going to include anything for this union, but just the next one, right? The elements from the second one. Okay, so what was this one? It's the set of the previous number, so it should be empty. So we are going to have this one. So this one is a set which has the empty set as its element. So one very important thing is this is not the empty set because it has an element, one element in it, right? So we cannot say this set equals empty set, right? No, okay, totally different. Okay? So don't be confused. Okay? This one is a set containing empty set as it's the only element in it. Okay? But eventually when you're adding them, right, take the union of it, it looks like this way, right? Like that. So that is for number 1. And using number notation, then this one is same as this one, right? Instead of 0, we can plug empty set, right? So it looks very strange for our eyes because we haven't done this one before, right? Like a number 1 union and set of number 1. What does that mean? Once again, number and sets are kind of same thing when you're developing these procedures. Okay? So these are just the union of two sets, right? Okay, then by doing that way, number 2, exactly same, right? So this is actually better notation to understand it, right? So eventually, when you have some n before, then n plus 1 equals n union a set of n, right? So that's the kind of general rules to developing the consecutive numbers, right? So let's just apply that one, and let me explain over here. Number 2 is union of 1 and set having number 1. Then number 1 was the set with empty set. So union, and the set of number 1, which is set having empty set, right? So in this case, when you take the union of it, be careful, this is not the empty set, right? It has some elements which is empty set, and from the second set, the elements looks like a set, right? So we have to include all of them as an element. Okay, that's how we got number 2 notation, right? So let's do the same thing for number 3. It's actually 2 union set having 2 as its element, right? But what is 2? We just have that, right? So set 2 has 2 elements, empty set and the set having empty set. And these 2 are the elements of number 2. And union, the next part is just repeat of exact same thing with extra braces around it, right? So when you put this, and this one is just that. So entirely, right? Don't miss anything. So brace, empty set, set with empty set, and closing one, right? So how many elements do we have in the first set? 1 and 2, right? How many elements do we have in the second set? Only 1, right? Because as entire set notation, that is just 1 element anyway. So altogether, how many elements do we expect? 3, right? Yeah, that's the natural kind of result of it. So the first one is empty, second one is empty as its elements, and third one is the entire one, right? So empty set like that, right? So you're gonna have many empty set notations and all the open close braces, right? So whenever you look at it as a whole picture, right? Like this, we have 3 elements in it, okay? And each element is a different style there. Okay, so that's how we develop our natural numbers in modern math. Okay? There are some other ways to do it. This is only one way, but most likely most of them are just approaching this kind of axiomatic systems, right? Which means we don't give any specific meanings on that number. So it's a kind of undefinable objects, okay, to treat the numbers. So don't try to give any meanings here. Number 1 means kind of I have 1 something. Don't treat that way. Just number 1 is just name of that function. That's it. Okay. How to construct the next set? Yeah, this is the kind of formula. So this is the kind of only formula to making these natural numbers. Okay, and collecting all that natural numbers, we use this boldface capital N, right? And natural numbers containing 1, 2, 3. Of course, in some culture, they include 0 there. But in our case, if we want to include 0, we use boldface W. So 0, 1, 2, 3, and we call that is whole number. So it's a set of whole numbers. Anyway, so let's find number 4 in this manner. Okay? And key point is you have to know what is set notation for number 3, right? So number 4 is simply 3 union set of 3, right? And 3 is empty, set of empty, and set of empty, and that, and that. Okay, so, but that is just only for number 3. We have to take the union of a set having that as the only elements, right? So set this one like that, right? So we have 3 elements. In this case, we have only 1 element. So when you take the union of it, we have to just put down all these elements from both sets, right? So empty, that one, this one. So be careful about the number of braces. And the last one is kind of repeat of those steps. Can you see that, right? How many braces do we need? So that brace is only for that. This brace is for that much, right? No, not this much. This much, right? And this brace is for that. And this brace is matching with like this, right? Anyway, that should be the answer for that question. Now, then the real question is, why we need this kind of complicated style of construction of natural numbers, right? What for? Isn't it better like, okay, so maybe like 0 is empty set, okay, then number 1 is just a set with an empty set. How about number 2 is just a set of that, right? So just take the brace that many times, right? Maybe it's better, right? Like that, right? Please thinking about it, right? It might be better if it's working, right? But the key point here is, in the traditional way of looking numbers, we have to develop another rules and the meanings of all the operations like addition, multiplication, subtraction, and division. That's 4 operations, right? And it's quite difficult to explain it, right? Can you explain what is the meaning of 2 times 3? When you were in the elementary school, yeah, we were taught like, oh, it means 3 apples, 2 bags of 3 apples, right? Or 3 bags of 2 apples. Okay? So how many apples in there is 6. So that's the meaning of multiplication, right? Division is a kind of sharing and cut pies, right? You see, right? You remember all this long process of understanding of these operations, right? Now, in this way, in this new way, actually, the way of constructing each number, it really tells us how to add and how to multiply naturally in it. Okay? So that's why in the beginning it looks like very complicated, but it has its own explanation of those operations. So that's why we choose this method. So let's look at the next case. Then how about addition? Okay, how can you understand the meaning of addition? So what is n plus 1? That's how we made or set it, right? To construct those natural numbers, right? Okay, then what is meaning of n plus 2? Okay, in this case, we understand 2 is what? Is 1 plus 1 in this case, right? We just accept that concept. Then instead of that, we can have n plus 1 is n plus 1 plus 1. And n plus 1 is that, which becomes really n plus 1, right? That's the meaning here. And the next one is just adding 1. So it's the 2 times later from n, right? Whatever the number is, we just got that, okay? So, because we don't know the exact shape of n, right? N should be a set, so we are going to have a bunch of elements, actually n of them in there. To write down all of them is really difficult, right? So n is just a kind of name of such set. Remember that. And after that, we want to get n plus 1 and n plus 2. So we can understand the meanings of these. Okay, n plus 1 means n union set of n, right, together. And plus 1 is again, so look at here, there are slight difference here. Here is open close parenthesis, right? That is braces, so big difference. Yes, the meaning is like that. Let me translate the meaning here. At this moment, let me say kind of box, okay, is for the number n plus 1. That's new symbol that I want to use for n plus 1. Okay. Then this one change to box plus 1. Okay, but n plus 1, remember, should looks like what? Starting with n and union set of n, right? Okay, so box is for that entirely. So when you're thinking about box plus 1, if you follow that rule, it should be box union set of box, right? So what is box? This one, right? So that is n union set of n, right? And union of new set which has box. Okay? So n union n, right? So that open close parenthesis means it's just that portion is came from that one single box, and this brace portion is came from just repeat of that. Okay, you follow me? So it just follow this rule. Okay, and these are just kind of emphasizing this one came from that part, right? So if you write down this one again, it's same as just n union set of n union set of n union n, right? So it's kind of union of 3 different sets. Once again, that is also a set, right? Okay, so in previous case, when you're developing the number systems, the meaning of those, we didn't use the plus 1, right? We just look at how to get the success of each number, and that was the definition, right? Okay. But now we could develop the meaning of addition, right? Which already used here, but let's just look at starting from 1 plus 1. Okay. So we already know 0 was empty set, and therefore the natural one, the next number 1 was kind of empty set union. Let me give this way: 0 union set of 0, right? And 0 was empty set, so we can put this way. And empty set doesn't have any elements on it. The union is just same as this one. That's a very special case like that. Okay, then we are not asking what is 2. No. What you want to do is what is meaning of 1 plus 1. So 1 plus 1. And when you look at the previous method, right, this is the formula for that. So 1 was this one, right? Okay. And plus 1, that's the meaning. So we are kind of treat them in a different way, right? Then according to that definition, the meaning of plus 1 is really using this one, union and set of it. So when you get it, it's empty set and set of empty set, and it turns out that form is same as number 2, right? So we got number 2, by that. So according to this method, kind of one of the most difficult case is when you're adding 0 to any integer. So for example, like this case. So let me just show you this answer. So n plus 0, then whatever n, that is a set, right? And adding 0 is take the union with 0, which is empty set, right? So it becomes n. So in this case, that's the kind of special case of it. You can treat that. But the next one, we already have that case, like a 2 plus 2. It's not 2 union 2, okay, be careful. But that's same as just 2 plus 1 plus 1. So the meanings of each case are different. This is set 2, but that is just looking for the next number, the successor of it, and successor of it, right? So you have to treat that way. So 2 plus 2 means 2 times successor of number 2, right? So how to get it? Looking for the next successor of 2, and after you found it, the successor of it again, like that, right? So you have to do one at a time. And 2 plus 1 is 2 union number 2, right? And you can write down the notation as it is. And after we have it, then this is a set, right? And meaning of plus 1 is, repeat this, right? 2 union 2 and union set of that 2, right? So we are looking for union of 3 sets, right? So all we need is what is 2, right? Okay. So you are going to have a bunch of the braces, right? So be careful. Okay. So please show me that result. Okay. Okay, so we finish how to get the addition natural numbers, and I already explained this one, right? These are the notation for positive integers, natural numbers, non-negative integers, or whole numbers, right? Now then, how can you so what I mean is, for the multiplication is treat like for example 2 multiplied by 3 the same as 2 kind of plus 2 plus 2, right? It's the same concept like we have used. Then the meaning is we can have 2 plus 2 and plus 2, and 2 plus 2 is starting from 2 and looking for the successor of it and successor of it. Then the plus 2 means looking for the successor of it and of it, right? Like that. So when you look at this whole together, it looks like we are looking for this number, right? So starting from here and doing all this stuff like that. Okay. So in this case, it doesn't give you how the kind of nice formula to get the answer right away, right? These are just concepts. And the meaning of this plus 2, the second number, is not the number directly, right? But it's whether we want to looking for that many successor from the previous number. Okay, so, and we are going to dealing with those steps in the next chapter, talking about the integers. So this concept is actually starting from the piano, and he was in the second parts of the 19th century, and he actually formulated this whole number system using this axiomatic style. So he gave that 4 axioms, and using this we are going to get kind of natural way to define the natural numbers, okay, the positive integers. The first one is each natural number has a unique successor, right? Okay, so by doing that, we can guarantee there is only one number will be assigned at n plus 1, right? Because of the uniqueness of the successor. The second one, there is a natural number 1 that is not the successor of any natural number. So the meaning of this statement is there is a starting first element in natural number system, right? It going further, but there is no going back. Okay, so you have to start from 1. Number 3, two distinct integers cannot have the same successor. Okay, number 1 means when in the middle of these natural numbers, there is a unique way to get the next successor. Okay, but the number 3 means, who knows, maybe there is something, right? The meaning of successor we haven't defined yet, right? So maybe there are something beforehand, and its successors might be also this one. So still it's satisfying number 1, right? This one has its unique successor, right? This one has its also unique successor, okay? But by the number 3, if it happens like this, then these two numbers should be same number, right? So meaning is, it's a linear order, right? You can make some kind of linear shape orders among the natural numbers. You cannot have like this crazy style diagram of numbers. So by doing this, we have kind of nice ordering system in natural number. Okay, by doing that. And number 4, M is a set of natural numbers which contains number 1. And if any natural number n is in that set, then its successor of n is also in M. Okay? So if we satisfy all these conditions, then every natural number is in M. And this one guarantees the principle of mathematical induction. Just imagine like we have natural number set 1, 2, and n all the way, and it's nicely ordered, right, like that. And let's just choose M. It's a subset of natural number set. We don't know which one is in there, but the first thing is, yeah, 1 is there. And second one says, if n is in M, then we guarantee n plus 1 is also there. That's all, right? So if it has certain number there, then n plus 1 must be there. So it only guarantees those two conditions. Then suddenly, this entire set becomes natural number set. Because of this rule, 1 is there, which means its successor 2 should be there. And because 2 is there, its successor 3 must be there, right? And keep doing it. So that's the mathematical induction, right? So this is maybe the most important properties of natural number set. There are much more really interesting and great ideas and concepts here, but it might take in number theory or some other courses. Okay. The homework problems. This is going to be really complicated if you just treat that as a just net in general way. So please give this kind of notation, like a condition, like m is less than n, and like there is kind of d which makes n, right? Okay, so adding these more extra conditions, and please do this part. And still it might take a lot of kind of work, right? Because you have to explain it in general cases, right? Please try, okay? Okay, that's the end of chapter 18.